So there's a really good diagram. Here's the soil with the nitrates. There's nitrogen in the air that we breathe. So as I said, it's 78% of all elements in the world. So I think protein is pretty essential to eat and have. Nitrogen in plants, which is another protein. So it says decay of dead plants that go in the soil. It says lightning and rain into the soil. I can't read that upside down. Hang on. The plants get eaten by the animals, and then their feces of decay and dead bodies go into the soil, which is nitrate. And lastly, what's that one? Ooh, denitrification bacteria. Okay, I'm going to have to look up that word. Denitrifying bacteria. The nitrogen circle. Yeah. Okay, so coming back to protein. Figure 10, yeah, so I showed you the diagram of what protein looks like. So protein is made up of one or more chains of amino acid, and there's 20 amino acids. Short length of amino acids are called peptides, while those that are up to about 100 amino acids are called polypeptides. There are about 20 naturally occurring amino acids, as I said before, which are found in protein. So we've got protein, we've got nitrogen, and 20 amino acids. Right, and then it's A6. Where's A6? So there, we do know the exact order of protein, like the 20 amino acids are in an exact order. Then it's crucial to know that, and is genetically made by the messenger RNA, which is there we go. RNA. Short for ribonucleic acid. It's a complex single-stranded molecule important in making proteins. So that's also in our protein. It's spelled RIBONUCLEIS, acid. ACID. Okay, so what else? Proteins can be classified chemically or by shape, which I didn't know that. Chemically, the simple proteins are made only of amino acids. It's like we've got another two names, so we've got ALBUMIDNIN, sorry, not D. And so that's albin and globulin. So GLOBULINS. You can look those up. LRB. Oh, here we go. Okay, LRB. So albumin is a group of water-soluble proteins found in blood, which is important to maintaining correct concentration of blood relative to cells. Okay, so that's like plasma. That's another word for plasma. So that's in protein. That would be the, in where you've got the steak, like you've got the plasma that comes out of it as well. Or when you take blood, you can get plasma or blood. Anyway. Conjunction proteins are covalently bonded to non-protein substances. Glyco. Okay, have we had that before? Glyco. So one of the 20 amino acids can be covalently bonded as to make a polysaccharide. Lip proteins. Oh, and another example is lip proteins to lipids. And so say if you have high lipids, it's like a high protein. Let me just double check that one. But that's what I think. There's two general shapes of proteins that are called fibrous and globular. And we had that word similar just before. So I'm going to look that up. It's GLO. Here we go. So the first one we came across was globulin. Is any of the group of the relative simple animal and plant proteins which is insoluble in water but soluble in fats in salt solution and are congealed by heat. Okay, so let's say if an animal or a plant has this, for us to, I guess, eat it, we'll have to put salt on it. So it's soluble in salt. And is coagulated? No, hang on. Coagulated by heat. Yeah. Amongst the globins are the main protein in plant seeds. Okay, so plants have that one. And I'll read the other word we came across with is globula, which is just above here. Globular proteins that fold to a shape, compact three-dimensional shapes, or to form compact three-dimensional shapes. Which, coming back to this one here, that squiggly line one, that's what hemoglobin looks like. This is contrast to the linear shapes of the fibrous proteins, like the one below. So it's similar sounding. It's so hemoglobin is LAR protein. Plant is LIN. Okay, so fibrous fibrous proteins are linear, yeah, and structured like collagen and creatine, and contractile. Oh, and myosin, actin, and function. The globia, so AR, is the hemoglobin proteins have a more complex and often very exact three-dimensional shape, and the functions as hormones, antibodies, and enzymes. All right. I guess I haven't really answered like why we need protein on a low-fat diet, but I think I've covered a few points where we definitely need like all these things, and it's found in protein. So best to Google up like what the most like food items have the highest protein, because it's pretty essential. Thanks for your time. Bye.